guys, this is Joey from Linbay Machinery. Welcome back to our channel. Today we are testing the production line of the stipple beam with multiple sizes automatically. And the stipple beams are designed to connect to the uprights and secured in place to ensure safe and reliable storage. The stipple beams are made of the cut rolled steel or hot rolled steel with a thickness of 1.5 to 2 mm or gauge 16 and gauge 14. Let's see more details with me. The production line starts from this part. It's a very efficient machine combined with the decoiler and the leveling machine. This is a hydraulic decoiler with the loading capacity of 3 tons. And as you can see, this is a press arm. This press arm can press on the steel coil, form its spring open. It's for the safety of the workers. And this is the coil expansion. It adjusts the inner expansion ranging from 460 mm to 520 mm, suitable for the steel coils of different inner diameters. And if there are not overhead cranes in your workshop, this loading car can assist in replacing steel coils. The loading car is capable of moving forward and backward, as well as ascending and descending. It's a very efficient machine. And then the steel coil will go into the leveling machine. For the steel coil with a thickness over 1.5 mm, it's very necessary to use the leveling machine to bend the coil back, to put the steel coil surface flat and relieving the inner stress in the steel coil. And then the steel coil will go into the punching machine. Let's go and see. This is the punching machine. We use the punching machine from the Yanli brand, a brand with multiple offices worldwide, providing convenient after-sales service to our clients. This is the punching machine with a punching force of 80 ton-pounds. The 80 tons is already enough to meet the punch requirements on the material with a thickness over 1.5 mm. And let's see some details. This is the servo feeder. We use the servo motor because it almost has no start time delay, so it can guarantee the accuracy, punch positions, and control the movement distance area within 1 mm. The slotted holes on the steel coil are designed for tapped and drop-in crossbars, and then the steel coil will go into another part, the limiter. Let's see. The limiter is designed to coordinate the production line of the whole speed. And this is the lower sensor. This is the upper sensor. When the steel coil touches the lower sensor, it means the punching speed is higher than the roll forming speed, and the punching machine stops working after receiving the signal from the PLC control cabinet. And a promote alarm appears on the PLC screen, and the operator should click on the PLC screen to restart the punching machine. And when the steel coil touches the upper sensor, it means the roll forming speed is higher than the punching speed, and also the roll forming machine stops working and should be restarted after the operator clicks on the screen. With the limiter, we can control the production speed efficiency higher, and then the steel coil will go into the roll forming machine. Before the roll forming part, the steel coil will go through the guiding part. These guiding rollers keep the steel coils and the machines on the same center line to guarantee the straightness of the profile. This is the roll forming structure. This roll forming machine adopts the cast iron structure, which is made of a whole piece solid steel. It can provide long service life and has high strength. These rollers are driven by the gearbox system, and to force the steel coil goes through and force the rollers. During the forming process, the steel coils undergoes gradual forming, and it achieves the shapes specified in the drawings after in total 28 roll forming stations. And see, the roll forming machine can change the size automatically after receiving the signals from the PLC control cabinet. And to change the size, the workers just needed to improve the size they want to produce. The roll forming stations can move on the rails, and the forming points are changed as the movement of the roll forming stations. Considering the safety of the movement of the roll forming stations, here are two distance sensors. I sit both left side and right side, in total 4 distance sensors. This is the outermost sensor. This is the innermost sensor. This outermost sensor is set to prevent the roll forming stations from getting too far and slipping from the reels. And the innermost sensor is designed to prevent the roll forming stations from getting too close and causing roller collisions. We do this design for the safety of the movement. And then let's see more details. This is the full welding machine, and this is the laser welding torch. The laser welding is applied at every junction to ensure a stronger bond at every connection lines and provide a higher loading capacity of the step beams. This is the hydraulic cutting machine, and on the step beam's bottom there is a rectangular hole allowing the cutting blade enter and cutting downward without causing any deformation to the cutting edges. To enhance the production line speed, the cutting base can move forward and backward at the same speed as the roll forming machine. So the roll forming machine doesn't need to stop when cutting. This is the servo motor to control the movement of the cutting base. The servo motor almost have no time to delay, so it can control the movement accuracy within 1 millimeter. And this is the whole production line for the step beams. One production line like this requires about 90 working days to complete. And if you are interested in this machine, please feel free to contact us and we will plan production for you to ensure the timely start to your project. And we provide the warranty of 24 months for the whole production line and 5 years for the motor, shafts and rollers. Please feel free to contact us. This is Joey. See you next time.